The next section focuses on organometallic reagents. And the most important feature of an organometallic reagent is that it contains a carbon to metal bond. And this is going to change what we've seen normally from carbon in the past, because normally our carbons have been positively charged or have partial positives because of being bonded to more electronegative atoms. However, metals are all less electronegative than carbon. So what we're going to see is a delta minus on carbon and a delta plus on the metal. So an example of an organometallic compound might be something like butyl lithium. However, something like sodium methoxide is not an organometallic because the sodium is bonded to oxygen, not to carbon. There are three main categories of organometallics that we'll look at. We'll look at organolithium compounds. We'll look at organomagnesium halides, which are also called Grignard reagents. And we'll also look at organocuprates, which typically have a lithium to balance the charge. So sometimes they're called organocuprates or organolithium cuprates. These are also sometimes called Gilman reagents. So what makes organometallic reagents interesting is how they react. What they react like is they react like we have our carbon side with a negative charge and the metal side with a positive charge. So instead of our carbon being an electrophile like it has been for all the reactions we've been seeing so far, our carbon now can be a nucleophile. If we want to look at the reactivity order of the organometallic reagents that we're looking at now, the organolithium compounds are going to be the most reactive. The Grignard carbon-magnesium compounds are going to be moderate. And the carbon-copper compounds are going to be the least reactive. Now there's a good reason for that, which gets back to one of our 5 main principles, which is electronegativity and polarity. So the electronegativity of carbon is 2.5, while lithium is 1.0, magnesium is 1.3, and copper is 1.8. So the great difference between carbon and lithium means that this bond is highly polar. It's very close to being a full carbon minus and a full lithium plus. So because of that, this carbon nucleophile is going to be very reactive. The difference between copper and carbon, when it's 1.8 to 2.5, is not such a great difference. It's a more covalent bond, less polar. It's still polar, but it's going to be much less polar than a carbon-lithium bond. So these are going to be much less reactive. So how do we make organolithium compounds? We can start with a generic alkyl halide and react that with 2 equivalents of lithium metal. What you end up getting is you get 1 alkyl lithium compound plus 1 lithium halide. So we can draw a specific example of that is if we have butyl bromide plus 2 lithium, it can go to butyl lithium plus lithium bromide. And you may have never seen lithium react before, but lithium is highly reactive. If you think of sodium metal, hopefully a lot of you have seen the reaction of sodium metal with water. If not, you can go on YouTube and find a cool video that will show sodium metal reacting with water. And it's so highly reactive that it actually will catch fire and explode. The reaction for preparing Grignards looks sort of the same, but actually the mechanism is quite different and the end result is quite different. So again, we can start with Rx, some kind of alkyl halide, and react that with magnesium. But now, instead of the magnesium displacing the halogen, like happened up here with the lithium came in and displaced the halogen. The magnesium inserts between the halogen and the alkyl group. And we can do a specific example of this as well. So if I take propyl chloride plus magnesium metal, I can get propyl magnesium chloride. If you take advanced inorganic chemistry, you'll learn more about these type of reactions where we have an insertion type of reaction. We don't talk about those very much in organic. And then finally, we'll look at the preparation of Gilman reagents. If we start with 2 alkyl lithium compounds, okay, so we're starting with an organometallic compound and a much more reactive one. We can react that with copper iodide. And what we get is we get 2 R groups adding to the copper to make our dialkyl lithium cuprate. And we get 1 equivalent of lithium iodide as well. And again, we can do a specific one. So we can have 2 equivalents of, say, methyl lithium, and react that with copper iodide to form dimethyl lithium cuprate. Plus lithium iodide.